All right, so you're with us again for another deep dive into the wild world of machine learning research.
Always exciting stuff.
Right. And today we're looking at, well, it's a paper with a bit of a mouthful of a title. ReAgent. Reversible multi-agent reasoning for knowledge-enhanced multi-hop QA.
Yeah, that's a lot to unpack.
But don't worry, we'll break it down. The gist is, this paper tackles a pretty critical challenge in how AI systems handle those really complex questions, the ones that need multiple steps of reasoning, what they call multi-hop.
Right, multi-hop question answering, a big deal in the field right now.
And the problem is, well, think of it like this. When AI tries to answer these questions, it's often building up an answer piece by piece.
Like a chain of thought.
Exactly, a chain of thought. But the problem, and this is where things get tricky, is that if the AI makes a mistake early on...
Oh, it can completely derail the whole process.
Right, one wrong turn and the whole answer goes off the rails. And what this paper highlights is that a lot of current AI systems, they don't have a good way to go back and fix those early errors.
No do-overs.
Pretty much. So they get stuck with a wrong answer even if the later steps are perfectly illogical.
It's a fundamental limitation, actually, of a lot of current approaches.
So this ReAgent system, it's trying to change that, right?
Yeah, they're proposing a new approach, a more dynamic way for AI to reason, one where it can actually backtrack and correct mistakes along the way.
So instead of being stuck on that one-way track...
They're introducing the idea of reversibility.
So how's it work?
Well, instead of just a single AI plowing ahead, imagine having a whole team of AI agents.
A team effort?
Yeah, and each agent has a specialized role. Some break down the question, some search for information, some check the facts, and others assemble the answer.
Like a well-oiled machine, hopefully.
Well, that's the goal. And crucially, these agents can communicate, check each other's work, and most importantly, they can backtrack if they spot an error. So if one agent realizes, hey, this piece of information doesn't fit, it can trigger a correction.
So it's not just about finding an answer, it's about making sure it's the right answer.
Exactly. And this is particularly important in those multi-hop scenarios, where the AI needs to connect the dots from different sources or reason through multiple steps. Existing methods, they mostly just charge forward, hoping for the best.
Fingers crossed.
More or less. But ReAgent, it tries to bake that error correction right into the process itself.
I'm really curious to see how this actually plays out, but before we get into those nitty-gritty details, I think it's helpful to take a step back, look at the bigger picture.
The historical context, you mean?
Yeah, like how did we even get to this point where we're talking about teams of AI agents and reversible reasoning? What came before?
Well, if you look at the history of question answering systems in AI, it's been a steady march toward tackling more and more complex scenarios.
From simple stuff to these really intricate multi-step problems.
Exactly. In the beginning, AI could handle those straightforward single-hop questions like, what's the capital of France?
But then we started asking tougher things.
And researchers started developing more sophisticated techniques.
Right, like those large language models we hear so much about.
And things like chain of thought prompting, where the AI actually explains its reasoning steps, which is super helpful for us to see what's going on in their artificial minds.
But even with all these advancements, the issue of error propagation within that reasoning process, it kind of lingered.
It did, and the paper does a good job of pointing that out. You know, an early mistake can still cascade through the whole system, messing up the final answer.
So ReAgent is building on all this past work, but specifically addressing that gap.
Right, they're saying, look, transparency is great, but we also need mechanisms to actively correct those errors as they happen.
So let's dive into that. How does ReAgent actually achieve this reversible reasoning? You mentioned different agents working together.
Right, so their system has a 3-layer architecture, each layer with its own set of responsibilities. First, you've got the execution layer.
Where the action happens.
Exactly. It's all about breaking down the question, retrieving relevant info, checking for consistency, and then assembling the answer. It's like the workhorse of the system.
Sounds busy.
Oh, it is. And then above that, you have the supervisory layer.
Keeping things in check.
Yeah, think of it like the manager. It steps in when there are conflicts between the agents, when things don't add up. And if a major issue crops up, it can initiate a global rewind, telling all the agents to go back to a point where everything was consistent.
Like a system-wide undo button?
Kinda, but smarter than that. And finally, there's the interaction layer, which is all about communication and coordination.
Making sure everyone's on the same page.
Right. The agents need to talk to each other, keep track of what's happening, handle things that occur simultaneously. So this layer handles all that.
Okay, so we've got these layers, but what about those specialized agents you mentioned? How do they actually fit into this?
Right, so within that execution layer, you have a bunch of agents, each with its own task. There's the question decomposer agent, which, as the name suggests, takes a complex question and breaks it down into smaller, more manageable sub-questions.
It's divide and conquer.
Exactly. Then you've got the retriever agent, which goes out and finds relevant information for each sub-question. It might search through documents, knowledge bases, or whatever's available, and it might even assign confidence scores to the information it finds, kind of like saying, I'm pretty sure this is relevant, but I'm not totally certain about that one.
So it's got some judgment.
Right. It's not just blindly grabbing things. And then there's the verifier agent, which is super important.
That fact checker we were talking about.
Exactly. It's constantly asking, does this new information fit with what we already know? Are there any contradictions? And if it spots a conflict, it can trigger a local backtrack, meaning that specific agent goes back and reconsiders its last step.
So errors get caught early on.
Ideally, yes. And finally, there's the answer assembler agent, which takes all the verified information and tries to piece together a coherent answer. But if it runs into a major inconsistency, something it can't resolve locally, it escalates the issue to that supervisory layer.
Calling in the big guns.
And that's where those supervisor and controller agents come in, right? They handle those trickier situations where a local backtrack just isn't enough.
So walk me through that. How do they manage those bigger conflicts?
Okay, so say the verifier agent spots a contradiction, but local backtracking doesn't fix it. Now the supervisor agent steps in. Its job is to look at the bigger picture, identify the core pieces of information that are causing the conflict, and then, if necessary, initiate a global rollback.
So everyone goes back to a safe point.
Exactly. It's like saying, okay, team, something's not adding up here. Let's rewind to a point where everything made sense and try again.
And what about that controller agent, the strategic overseer you mentioned?
Yeah, the controller's interesting. It can kind of step back even further and question the overall strategy. It might override a local decision if it thinks the system is stuck in a rut, or it might challenge a seemingly obvious assumption just to make sure everything is truly solid.
So it's adding another layer of checks and balances.
Right. And all of this together, the agents, the layers, the backtracking mechanisms, it's all geared towards this idea of non-monotonic reasoning.
Non-monotonic, now there's a fancy word.
Yeah. But it's not as complicated as it sounds. It basically means that the system doesn't just keep adding information blindly.
It's okay to go back, unlearn things.
Exactly. New information doesn't always mean better information. Sometimes you need to revise what you thought you knew, go back to a previous state. And that's what makes ReAgent so interesting, this ability to retract conclusions when the evidence suggests they were wrong.
And doing that efficiently, right? Not
Yeah.
just starting from scratch every time.
Right, the paper emphasizes that. Being able to directly target the problematic step and revise from there, that's much more efficient than blindly pushing forward with contradictory information.
Okay, so that's how they handle those conflicts. But what about the actual process? How does all this play out in a real question answering scenario? Do they have like a step-by-step breakdown?
Yeah, they actually provide a pretty detailed algorithm outlining the whole multi-agent reversible reasoning process.
So walk us through that if you can.
Sure. It starts with the question decomposer agent, breaking down the complex question into those sub-questions.
Like we talked about.
Then the retriever agent goes and finds relevant information, maybe with confidence scores attached.
So far, so good.
Then the verifier agent gets to work, checking for those local conflicts. If something doesn't add up, it tries local backtracking. If that doesn't work, it signals a global conflict to the supervisor.
And then the supervisor takes over.
Right? It analyzes the situation, figures out the core inconsistencies, and decides if a global rollback is needed. And sometimes that controller agent might chime in, challenge an assumption, or suggest a different approach.
So it's this dynamic back and forth between the agents.
Exactly. And eventually, if all goes well, the answer assembler agent gathers all the verified information and puts together the final answer.
Hopefully the correct one.
And the whole process with the backtracking and the communication, it's all logged so you can actually trace back how the system arrived at the answer.
Okay, so that's the theory, but how does it actually perform?
Well, they tested it on those 3 challenging multi-hop QA data sets we mentioned earlier, HotpotQA, 2Wiki multi-hop QA, and music.
Really put it through its paces.
They did, and the results are pretty impressive. Across the board, ReAgent outperformed a bunch of other strong baseline models.
Including some of those really big, powerful language models we hear so much about.
Yeah, even those. And on average, ReAgent showed about a 6% improvement in accuracy.
That's significant, right?
Definitely. It suggests that this approach of incorporating reversibility It really does make a difference when it comes to handling complex reasoning tasks.
And they didn't just take their word for it, right? They did some more in-depth analysis to see what was really driving those improvements.
Right. They did an ablation study, which is basically where you remove a specific component of the system and see how it affects performance.
So what happened when they took away the backtracking?
Well, when they disabled that backtracking mechanism, the performance dropped noticeably across all the different base language models they tested.
So it really does seem to be a core part of why ReAgent works so well.
It does. And to really understand how this backtracking works in action, they included a case study in the paper.
Using a logic puzzle, right?
Yeah, it's a simple puzzle, but it perfectly illustrates how ReAgent can explore different possibilities, spot contradictions, and then go back and revise its assumptions to arrive at the correct solution.
So it's like a mini detective story.
Kinda. It shows how ReAgent can methodically eliminate wrong answers by detecting inconsistencies and backtracking to try a different path.
And this really highlights a weakness of those more linear step-by-step reasoning models.
Right. They can get stuck early on and never recover. But ReAgent, with its ability to iterate, check, and backtrack, it has a much better chance of finding the right answer, even if it takes a few tries.
Okay, so we've talked a lot about this backtracking idea, but I'm curious, is this a completely new concept, or does it have roots in earlier AI research?
It's actually not entirely new. The idea of backtracking has been around for a while, especially in areas like automated reasoning and knowledge representation.
So they're building on existing ideas.
Exactly. The paper even mentions truth maintenance systems from way back in the 70s, which were designed to deal with similar problems of revising beliefs when new, conflicting information comes up.
So ReAgent is taking those ideas and applying them in this new context of large language models and multi-hop question answering.
That's right. And what's particularly interesting is that they're doing this within a multi-agent framework.
Which isn't entirely new either, right?
No, there have been other multi-agent systems for question answering, but ReAgent stands out because of its fully integrated and reversible reasoning pipeline. Many earlier systems might have had agents that could double-check each other's work, but they didn't necessarily have this ability for each agent to independently backtrack and then propagate those corrections throughout the system.
So it's a more comprehensive approach to reversibility.
Exactly. And it builds on those advancements in transparency we saw with techniques like chain of thought prompting. But it goes a step further by explicitly addressing the need for reevaluation during the reasoning process.
So it's not just about explaining how you got to an answer. It's about being able to go back and fix mistakes along the way.
Right. And that's really the key takeaway here. They've successfully combined this idea of explicit backtracking with a multi-agent system, and it's led to some really promising results for multi-hop question answering.
So to recap, the big innovation here is that they've managed to build in this error correction mechanism during the reasoning process, not just afterwards.
And they've done that by using this clever multi-agent architecture, where each agent has a specialized role and they can all communicate and check each other's work.
And the experimental results really back up their claims, showing a clear improvement in accuracy over existing methods.
And plus, that case study with the logic puzzle, it really gives you a tangible understanding of how this backtracking works in practice.
Okay, so it's clear this approach has potential, but what about the bigger picture? What kind of real-world implications could this have?
Well, think about any situation where getting the right answer is absolutely critical.
Like high-stakes stuff.
Exactly, like medical diagnosis, legal reasoning, or any kind of complex problem solving where a small error early on could have major consequences.
So areas where reliability is paramount.
Right. And in those scenarios, this kind of reversible reasoning could be hugely valuable. It could help us build more robust and trustworthy AI systems that we can rely on to make important decisions.
And it's not just about the accuracy, right? It's also about the transparency.
Oh, absolutely. The fact that you can trace back the reasoning process, see how the system identified and corrected errors, that's huge for building trust in these AI systems.
It's like having an audit trail for the AI's thought process.
Exactly. It can pave the way for AI that's not just more accurate, but also more explainable, which is something we desperately need as these systems become more and more integrated into our lives.
Of course, no system is perfect, and the researchers themselves point out some limitations of their approach.
Right. They acknowledge that there's some overhead involved in managing all these agents, and it can be computationally expensive, especially as the complexity of the task increases.
And they also point out that the system is only as good as the information it's working with.
Right. If the initial information retrieval is flawed, or if the underlying language model isn't very good at verifying facts, then the whole system will suffer.
So there's still work to be done on those fronts.
Definitely. And scaling this approach to handle truly massive amounts of information, that's another challenge they highlight.
So it's a promising start, but there's always room for improvement.
Absolutely. But this research definitely opens up some exciting new avenues for future exploration.
Which brings us to our novel notions segment, where we like to brainstorm a bit, build on the ideas presented in the paper, and see where they might lead.
So picking up on that idea of reversibility, I was thinking, what if we could make the conflict resolution process even more sophisticated?
Like, go beyond that simple rollback mechanism.
Yeah, what if we introduced a negotiation phase? Instead of just automatically rewinding when there's a conflict, the agents involved could actually present their evidence and reasoning to the supervisor agent, which would act more like a mediator.
So instead of a hard reset, it's a more nuanced discussion.
Right, and this could lead to more efficient error correction because you might be able to preserve parts of the reasoning process that are still valid.
Instead of throwing the baby out with the bathwater, so to speak.
Exactly. And this kind of negotiation could be particularly useful when you're dealing with ambiguous information or situations where multiple interpretations are possible.
It's like adding a layer of human-like deliberation to the AI's thought process.
Mhm. And it ties in nicely with some of the recent work on using AI to debate complex topics, where the goal is to arrive at a more well-rounded conclusion by considering different perspectives.
It's like taking the best of both worlds, combining the speed and efficiency of AI with the nuanced judgment of human reasoning.
And another idea that I think would be worth exploring is using reinforcement learning to manage that backtracking process.
So instead of having fixed rules for when to backtrack, you'd have an AI agent learning the best strategy.
Exactly. This reinforcement learning agent could analyze past reasoning failures, identify patterns, and then learn to predict when backtracking is likely to be helpful and how far back to go.
So it could optimize the process, making it more efficient and less computationally expensive.
Right. It could learn to avoid unnecessary backtracking while still ensuring that errors are caught and corrected.
And this could be particularly valuable as these systems get larger and more complex.
Exactly. As the amount of information grows, efficiently managing that backtracking process becomes even more crucial.
So these are just a couple of ideas, but I think they highlight the potential of this ReAgent framework to inspire new research directions.
Yeah, it's a really interesting paper, and I'm curious to see where the field goes from here.
Of course, it's important to remember that these are just speculative ideas at this point, not fully fleshed out research proposals.
Right, but they're food for thought, and hopefully they'll spark some interesting discussions and maybe even lead to new breakthroughs in the field.
Absolutely. So to wrap things up, I think it's safe to say that this ReAgent paper presents a significant step forward in our quest to build more robust and reliable AI systems for complex question answering.
By directly addressing that challenge of error propagation, they've opened up a whole new way of thinking about how AI can reason and learn.
And this idea of reversible reasoning, I think it has far-reaching implications, not just for question answering, but for any task where accuracy and transparency are paramount.
It's a reminder that we don't always need to just make AI bigger and faster. Sometimes we need to step back and think about how to make it smarter, more adaptable, and more resilient.
And for anyone who's interested in diving deeper into the technical details of ReAgent, the link to the full research paper is in the description below.
Definitely check it out. It's a fascinating read.
And as always, we leave you with a final thought to ponder. As we continue to push the boundaries of AI, how do we strike that balance between the power of these systems and the need for them to be accountable, transparent, and ultimately trustworthy? It's a question that will only become more pressing as AI becomes more and more integrated into our lives. Thanks for joining us for another deep dive.
Until next time.